Analysis of harmonic motion. Harmonic motion, that is a mathematical technique used analyzing yung periodic functions. And signals, also pwede rin niya ma-analyze and by means of decomposing them into a series of a simple sine and cosine waves. So which does have varying values of frequencies and amplitudes, which is commonly known as your harmonic components. Now, this technique was early developed by mathematician and scientist, that is Joseph Fourier in the way back 19th century, and its applications of fields are including the mathematics, physics, and engineering, and the signal processing. Now, the basic harmonic analysis, that the periodic function can be represented by a sum of simple sine and cosine waves, so each with the different frequencies and amplitudes. Now, by decomposing them into a signal, it constitutes to a harmonic, and it becomes easier. So it will be mas madali natin siya ma-analyze and to manipulate the equation in such a way yung harmonic can be studied separately and pwede natin i-combine to form isang one original signal. You will notice here, I bring down image. So this is a simple harmonic motion. So meron tayong amplitude going up, and mapapansin nyo, it go back to its original, which is yung 0. So it go back to original. Then if we have the function here going to become a negative, and again cycle na siya as we ang rotation ng vibratory motion mo. So that is a cycle, no? Periodic function na yan siya. Isa pang example ay ito, no? So we have here motion. Now again, so from here makita mo mag-rotate siya at it reaches to peak, so that will be ang amplitude natin siya. Then papunta siya dito, so that is going down, then back to its original, which is yung center niya, which is 0. Okay? Then again, it will go to a negative values of my function. So from yan, then akit na naman, then again, that is a cycle. So sinusoidal cycle, and that is a one cycle from starting here to going here. So the same also here, if you're going to want to define yung in terms of y-axis naman niya, no? So this is this is for my y-axis. Now for the x-axis, can be defined. So again, that is also a sinusoidal functions. Kasi pag sinabi mo kasing harmonic motion, so that is a type of periodic motion. So periodic, in which the object oscillates back and forth. So katulad yan, parang wiggle, no? So that is wiggling back and forth. So that is a sine wave. So not a sine wave, but a waveform, no? So yan. So oscillating back and forth around equilibrium position with a fixed amplitude. So we have here a fixed amplitude and frequency. So fixed amplitude, so we have here, so oscillating harmonically up and down, and we have your angular velocity mo, your frequency that defines also the frequency ng motion natin. So then, so that defines yung harmonic motion, and it can be used by can be solved by using the Fourier series. There are times harmonic motion are not periodic. No, hindi siya especially sa mechanical, meron tayong mga motion which are not in harmonic type, no? Tulad ng ganito. Now this type of motion is not a harmonic one, no? Mapapansin nyo, there is not parang katulad nito, so magkaiba sila, di ba? So merong sinusoidal wave na up and down, but this one is up, down, then going up and down, up and down. So especially we have here interpretation ng motion ng camshaft, which is especially sumusunod din yung cam follower, then are active by your spring and valves. So every time na it reaches the maximum, this is the maximum point, which is yung amplitude mo, okay, then afterwards, So, yun, biglang na siyang babagsak to 0. Then again, bubuelo ulit, then going up. Then we have here yung peak, no? Amplitude niya, then yan. So, ganyan is not a form of harmonic motion. Now, luckily, so this can be modeled by using, pwede pa rin gamitin ng Fourier series. Now, sabi naman, that is any periodic function of the time, which is a function of time, so can be represented by using a Fourier series. So, just make sure it is a periodic function. So, yung parang paulit-ulit, no? Periodic, no? So, parang katulad ng sinusoidal that is wiggling up and down. So, this is also moving up and down, which is paulit-ulit. So, it can be represented of using a Fourier series. Now, from the book definition, okay, so yung Fourier series is an important part of Fourier analysis. So, these are infinite series which represents periodic functions. So, we're going to represent that is in terms of cosine and sine functions. So, yung Fourier series are used in ordinary differential equations. So, we have the ODE and connection with the force oscillation. So, when we say force oscillation, so that is, again, parang wiggling pa rin. So, parang wave, no? And approximation of a periodic function. So, again, so when we say approximation, that is not totally yung nagiging value, but, again, approximation, that is estimate, no? When we say kasi, approximation, no? Usually if you're going to, pag i-model natin siya, kasi usually from here, yung parang tutso, no? Tutso motion. So, if you're going to use the Fourier series, so that is a form of approximation. So, yan. So, we have yung wave, no? That using the Fourier series, or using the cosine and sine, no? Sine motion, so usually representing by wave, no? So makikita niyan, so that is purely an approximation. So the number, makikita niyo, we have here one term of approximation. So one term of approximation, malayo siya, and then as you increase the number of terms of approximation, so it will be closer, paliit na siya, no? So until at such a time na sobrang liit na niya ng kanyang motion ng wiggling, so it also sobrang liit na niya, so that is also flattening the values here. So nasusundan na niya yung wave na ito, no? Okay. So yun ang definition niya. Then, so moreover, for Fourier analysis and can be used also to solve a partial differential equation and PDE, and such as heat conduction equation. So, for our application in vibration, so we will merely concerned with the motion ng ating oscillating motion or periodic function. So, that's why we'll be using the Fourier series. Now, Fourier series are defined as the infinite series that represents the periodic function in terms of sine and sine terms. So, for my function, okay, for my functions here, for my functions, so I have my functions dito. So, the function of x, no? So, this is equal to your a sub 0. So, this is all over, no? Divided by 2, then plus the summation, no? Summation to infinite with the number of terms starting at 1. We have here close bracket natin yan, where the Fourier series coefficient, where a sub n, so that is equal to the cosine, no? N, so that would be n pi x, okay? And this is all over divided by the L. So close bracket, parenthesis, then yan, then plus your b sub n, so that will be sine, no? Sine naman ito, then n pi x, then all over divided by your L. Okay, that is half of the period ng L na yan. Okay, close bracket natin yan. Then, to get the value of A0, A sub n, and B sub n, so we're going to integrate that one. So, where your A sub 0, that is equal to your 2 divided by over by your P, no? So, this is integrating uh, from the boundary where your period to negative period. Okay, so from both sides, from the x-axis. So to the function of x, so function mo of the motion, and dx. Then for my a sub n, so that will be again 2 divided by your p. Okay, then will be again the boundary from negative p to p, and we have again your function here. Then this time that is multiplied by the cosine of your n phi x, okay, divided by your L, and this is your dx. Now for my b sub n, so will be 2, no, all over divided by your p. Then integrate this one to the boundary of your p to negative p, and for your function, so this time we're using sine to get the coefficient. That will be again, so simple rin yan, phi x, kung yung value nyan doon, that will be L, and this is dx. Yeah. Now, for the value of your p, no, my p, yeah, this is my period. To get the value of my p, to get the value of my L, so the value of p, that will be 2L. Okay? So, yung L natin, eventually, just have to divide by 2 to yung period. You just have to divide the period by 2 to get the value of your L. Para i-substitute mo dito sa equation na yan. Okay? Now, in order for us to fully understand using application ng Fourier series, ano ito, sa sinusoidal motion or sa vibration. Now, let's have a sample problem. So, this is usually coming from the book. No? So, we'll try to scrutinize and solve this problem step by step. Now, determine the Fourier series expansion of the motion of the valve in a controller system shown. So, we have here yung bulb mo, camshaft mo, and you have your roller follower and your push rod, and we have your rocker arm with the corresponding spring para you can have your motion back and forth, no? So, para bumalik siya doon. Then, you have here the valve, so for opening, for intake ng hangin doon sa combustion chamber. Usually, that is the application, no? Okay. So, the first things I will do here, no, gagawin ko is that I will draw a schematic diagram, a free body diagram of this one representing. No? So, let me draw that one. So, that's a dotted line. So, gamit natin is a solid line. No? Okay. Then, we have here, you will notice here, so we have yung tawag natin y function, okay? So, mapapansin nyo dito, this is the motion ng push rod that is going up and down, okay? So, that means y is the distance that is moving up and down with the function of time. So, at a given time, so there is motion that is up and down. So, it depends on what time yung distance ng y. So, up and down. Okay? So, we have here the motion of the push rod that is up and down with the function of time. So, I'm going to draw this line to represent that line. Represent yan. Okay, so, here, the dotted line. So, this will be my y. No? This will be my y. Let me try to decrease the size of it. So, this will be my y a function of time. So that will be going up, no? Huh? And also, I have a motion naman ito, which is the motion ng bulb ko, which is up and down din. So, eventually, kasi if tinulak yung push rod dito, corresponding here, we have a pivot. So, eventually, tutulak din doon pababa. So, let me try to draw that one to represent yung y function natin. Okay. We have here, sorry, the x function. Oh, so, this is the motion of the bulb, no? So, to represent the motion of the bulb. Again, at the given of time, meron kang distance which is yung x, no? That is a function of time. So, at the given time, what is the function of, or the displacement or the movement of the bulb at the given time? So, may time siya. When the time is 0, natural, x is 0. But what the maximum time, mayroon siyang displacement. So, it depends on the given time, no? So, function is it's like a machine. So, equation, no? So, kung ano yung binigay mo na you have your function and you input the variable doon sa function mo, bibigyan ka ng ano, it's like a machine. So, it feeding you and it will give you output. Usually, ganun ang ano ng function, no? So, I have here the x at a function of time, no? Then, I have my distance L1 and L2. So, let me, again, draw a line to represent yung allocation na yan. So, this one will connect. Okay, so and also in the center, we have yung pivot nun, which represent yung ano, rotation. So, I will making here also yung distance. So, kailangan natin magpakita yung distance dito that representing to bisect yung distance na ito. So, we have this one. Okay. And we have this one. Okay. So, this is my, call this, ano yan, L sub 1. And ito naman ang aking L sub 2. No? And so, we have the distance L sub 1 and L sub 2. Now, we have here your angle. So, kung ilan yung maximum motion na yan, o theta. So, that represents your theta. And that is also equal din dito sa opposite side ng angle na yan. No? So, kung ano yung movement yun, the same also yung opposite niyan. So, they are equal. Okay? So, in terms of angle, these types of angle, yung tinatawag natin, they are called a similar triangle, no? So, since yung parang binisect mo lang siya, natin in opposite side, they have the same angle, no? But they don't have the same height, and they don't have the same length, no? This is, we can use later on, we'll try to use yung similar angle equations. Now, let's try to build the relationship. Since we are merely concerned the bulb motion. So, the problem states, determine the Fourier series expansion, motion of the bulb. So, yung x function of time is the motion of the bulb. So, let's try to build the relationship dito at saka doon, no? So, usually, we have the similar triangle na dito, no? So, yung theta at saka theta no, are equal, no? In order for me to build that one, so I can use the tangent tangent, no? Tangent. Okay. So tangent, okay, tangent of theta. Usually, what is my opposite? So that will be my y function of time, and this is all over, no? All over. Then yung adjacent natin, that will be L sub 1. Okay. And sa kabila naman, mapapansin nyo, we have here your x. No? Yung opposite ng angle nito, x, the function of time. And this is all over. And divided by yung sides niya, yung adjacent niya, that will be L sub 2. Okay. So, yeah. No? So, we have established the relationships between the y functions and my x functions. So, we build a relationship for that one. And furthermore, I can say since we are merely concerned by the motion of the bulb, no, I will try to manipulate my equation in such a way that we are all in terms of my x function of time, no? Diba? So I can rewrite this equation as y function of time times my L sub 2, and this is all over, no? Divided by my L sub 1. Yeah. So this represents now yung motion ng bulb. So my x, what will be the motion of my bulb? X will function of time. So ito na yung ating, which is y equal to y function of time, L sub 2 and L sub 1. No? Now, yung ano naman natin, y function. So going back ng kanina, no? So my y function, yung value natin, that is this one. So that will be y. So that is the amplitude of my y function, then times time over my period. No? So I will be substituting this one dito sa equation natin na ito in terms of x function of time. So I can say x function of time, no? So the value niyan, so that will be y. Okay, that will be times, no? Time over my period, okay? Then times my L sub 2, and this is all over, no? Divided by my L sub 1. Yeah? So I can say, or I can substitute yung values niya. Again. Now, let's have another relationships to represent it or to rewrite the equations natin na ito. No? So, going back to my triangle here, I can say, I can represent yung katulad niya. So, this is y. So, this is represent, going back here. So, that is the amplitude ng triangle. O yung toothed saw motion. So, yun yung amplitude natin, which is yung y. So, if I will draw here, no, dito, so this represents my, this is yung my, ano ko, yung y, no? So, this is my amplitude. So, usually, amplitude, no? So, this is my y. Okay? And on the other side naman, so since we don't have here yung, what is the value of this one? So, again, I'm gonna name this one as, denote this distance, yung height na ito ng ano to. So, rather than using the x as a function time, I'm gonna name this one as for my amplitude. So, usually this is my amplitude doon sa kabila at the motion ng push rod. But we are merely concerned sa motion naman ng bulb. So, I'm gonna gonna denote this one as my A to represent yung amplitude ng x to the function of time, motion ng ating bulb. So, from here, I can say that, furthermore, I can say that we can say yung relationship ng similar triangle, we have your A, no? So, similar relationships by means of the legs of the legs. So, legs ng triangle, legs. So, that will be A, no? So, this is divided by my, usually, the ratio. No? So, this one is the height. Okay, so we have the height. So, the ratio, we have A, tapos yung ratio mo doon sa kabila, that will be yung Y. So, that represents yung amplitude dito. And amplitude din doon. Huh? And also, that is already the height, no? Height na lang. Yan. Then, on the other side naman, okay, I can say, this is my, yung A, no? Yung leg niya, we have yung L sub 2, di ba? Okay. And we have on the other side, yung y niya, that will be L sub 1. Yeah? So, since we are merely concerned with the value of A, so since we are on the path of finding the bulb of the cam follower, no? So, I can rewrite my equation here as my y, that will be L sub 2. L sub 2 divided by my L sub 1. Okay, so that will be my value ng amplitude ko o yung height ng side na ito ng motion ng bulb. Huh? And I can substitute this one. So, pwede natin. Furthermore, we can substitute this one in this equation to represent yung x at a function of time. So, we have x, a function of time. So, yung value nito, the L sub 1 and L sub 2. Okay, so I can say ito dito are equal to y and y. So I can say that x, a function of time, so this will become my a, no? Times t, yeah? T all over my period, yeah? So we can see na ganyan siya. So I can represent my x, function of time, on this equation, which is a times my time over my amplitude. Divided by my amplitude. Now we have defined yung natin function of your motion, x, the function of time. So that defines the motion ng ating motion ng ating cam follower, right? So we have the function already. Okay, so take note, function is like a machine. So every time we enter the value here, so usually ang variable natin dito, this is time, no? So kaya nga lagay dito x is a function of time, no? So we have here yung variable mo is your time. So every time I want to change the value of time, so it will be giving me the amplitude, no? Or not actually the amplitude, but yung x niya to. So how much is the displacement, kung motion na ito kung ilan, no? So that determines so kung ilan yung time na nilagay ko doon sa aking machine, which is yung function. So which is yung function, so that is a machine, no? So pag binago ko yung time, so automatically it provides me the given distance of motion nung x kung nasaan na siya. Okay, so we have defined that one, so we are ready now to substitute this one to our equation, which is uh, ito, no? So, general equation natin, so that will be A0 plus the infinite summation and so on and so on. No? Bali, no? So, that will be expressing the cosine and sine functions. Now, in order to do that, so first things first, we need to define the value of A0, A sub n, B sub n, no? So, let's try to start with the value, determining the value of A sub 0. Okay? So, ito yung equation natin. So, I will start ako dito. So, for my A sub 0, okay, so again, so we have, initially, bali yan, we have your 2, di ba? Okay, so I'm gonna write here 2. Then, all over, no? So, for the period, let's go back to the problem. So, the problem states that we have the given period. So, we don't have here, okay, this one, okay? So if you're going to plot now, if we're going to plot this function, so which is a that is multiplied by t, and we have your period. So we have here your period, no? So if you're going to plot this one in x and y axis coordinates, so substituting different values of your a from 0 to infinite values, no? So eventually you will end up in this type of motion, which yung two-ted saw, no? So ano nang lagari, no? So that is from 0 to 5 to 5 and so on. Okay, so for my period here, I will be start using one period, no? So one period yung define yung equation na yung ano natin, yung given to the problem, no? So which define yung p natin. So I'm going to use here one period. Okay, so that one, and this is will be integrate again. So from period, from negative to positive boundary of your period. So going back here to the uh, drawing ng ano natin ng line, no? Mapapansin nyo dito, we don't have the negative, which is usually this is on the other side, yung kabila na yan. Wala tayo nun. But what we have is on the positive sides. So which is starting from 0. So start tayo dito sa 0. So we'll be starting from 0. So if you go back to my equation, so I'm gonna define my integration of my boundary. So I will be starting from 0 to my period, which is the symbol here, period, no? So yun, balikan natin yun. Okay, so we have here 0, tapos ito yung period natin. So that defines the boundary So, at which part tayo mag-integrate. Okay? So, again, let's go back here. Now, for the functions naman, so what is the functions about equations or functions uh, of the line of the graph na ito? Okay? So, let's go back this one. So, we have your function. So, ito yon. So, the function of x, so x, the function of time. So, ito yung function natin, which is yung tinatawag ko na earlier. I called it as a machine. So, every time na input ka ng value here, so it give you distance kung anong ipo-provides mo doon sa value na input ng function, which is yung variable, which is yung time, no? So, that will be a times t over your period. So, I will be substituting that one dito. So, ang function ko, that will be a. Okay? So, yan, we have yung time. So, again, that will be all over, no? So, that will be my period, close parenthesis. Now, in order here, mapapansin nyo, so what will be my, do sa equation that is dx, usually, what is the function? So, what is the variable na sa substitute natin, which is yung nagbabago-bago. So, usually, nagbabago-bago sa atin dito, that is distance, not the distance, but that is at the time. So, ang variable natin is time. So, I'm gonna differentiate here with respect to time. So, dt, no? So that is yung t, differential with your dt, no? So that to define the equation of initial value ng a sub o. Now, so ang mga constants natin here, so this one is yung a, yung amplitude constant yan, and also yung period is constant. So we can usually from your going back from your integral, so we can remove it from the integration since yung mga values na um, ang a at saka yung period are constant. So I can say, I can rewrite, no? So that will be my 2. So this is all over. That is my period. Okay. So again, so ilalabas ko ito. So that will be multiplied by a. No. So this one is also all over my period. So I'm gonna write here my period. And integrate natin. So again, the boundary. So we have your period and may iwan na sa loob, which is t dt. No? Is usually t dt is a form of your integral that can be integratable. So t and dt, no? So kaya yun ang hinahabol natin doon sa ating equation. Now, ang value naman natin ng period, no? So earlier, this is defined as yung value ng period natin. So I'm gonna write here. So separating this one. So ang value ng period natin, so may period that is equal to 2 pi, this is all over, no? Divided by my angular velocity. So yan. So I can express this equation, no? So I can rewrite here. So my a sub o, so that will be 2. That will be all over my this is my 2 pi over your w, and again this is, we have your amplitude dito sa kabila, so and all over, so this is 2 pi over your angular velocity. Then this one, that will be, I can rewrite this one as a 2 pi, no, over my angular velocity from 0, and this is t dt. Yeah, so I can rewrite it one. And also this one can be rewritten as, so usually we can cancel here yung 2, no? Or we can cancel here yung 2. So what is left, we have your amplitude, no? So we can combine this one, sorry, this will be a, no? Then all over, no? This is all over. So this will be 2 pi. 2 pi to. So that will be phi. And yung angular mo, lipat natin to sa taas. So this will be angular squared. So angular velocity squared, then this will be 2 phi squared na siya, di ba? So that define that one. And this one again, so I can rewrite this as a 2 phi angular velocity 0 integrating from 0 to 2 pi w or 1 period, then t dt. Okay, so from here, so I can rewrite this one, or let's say integrating that one, so I can say this is a w squared, that will be my line, that will be 2 pi squared. So this one, okay, I'm gonna draw the bracket here to represent yun. So gonna close parenthesis this one. Okay, so that will be t, you know? So this is t squared. This is will be all over my, usually pag integrate natin to, that will be, so that will be 1 plus 1, no? So usually this one is 1 plus 1, then all over by 2. Okay, so this is sa ilalim niya is 2, no? So sa ilalim niya is 2, and close bracket natin to siya since we have the boundary, which is 2 pi angular, then 0. Okay, then pwede pa natin ito expand this one, substituting natin yung mga value ng 2 pi tsaka yung 0. It will be a 0, no? So this is a amplitude, angular velocity squared. So this is all over. This will be my 2 pi squared. So this is 2 pi squared. So close parenthesis. So again, now we're going to substitute yung values ng ating boundary. So initially we have 2 pi, no? So this is 2 pi angular. So square ko ito, no? Then divided by 2, no? Then minus. So yun, yung 0 naman, so eventually it will be 0 out. Now just to demonstrate here. So para nakikita ninyo, no? So na we don't walang magic dito sa solutions na ito. Just only again, so that is purely application ng ano natin, going back to your integral calculus. So yan, no? So eventually 0 divided by 2 is usually that is again, so that is the value of 0 pa rin, no? So we have here yung a sub 0. So we have here angular velocity squared. So divided by my 2 phi squared. Yeah. Then close parenthesis natin yan. So we have here. So square this equation. So this will provide us 4. So usually is 2. 2 squared by 2. That will, yan. Then yung pi mo squared, that will be squared again. No? So this is all over. Now yung angular velocity, lipat ko na sa ilalim. So eventually ganun din naman yan. So this will be 2w and squared. So close parenthesis ko ito. So I have this one. Okay. Now let's try to cancel yung common terms natin dito. So we have your a sub 0. So I'm going to rewrite this one. So this one is cancelled out. Okay. So let me try to nating red to represent yan. Okay. So that will be red. Okay. So red line. So represent that one will be cancelled. And again, so this one also, no? Cancelled yan. Then may one dyan which is 2. And this one will be cancelled out and cancelled out. So also this one, pi squared, and also yung angular squared. So ang naiwan na lang natin, we have your a sub 0 is equal to your amplitude. Okay. So this defines yung values natin here. So I'm trying to underline this one. Okay. So we have your a sub 0. So that is the value of your amplitude, no? Okay. The next, we need to find the value of your a sub n. So we have here yung equation natin for your a sub n. Okay, so again, so we have to substitute. So let me write here a sub n. So again, we have your period. So this is all over, no? Yung period natin. So we have your symbol here. Then integrating this one. So this is your period. So again, so let me go back again yung boundaries natin dito, no? So we have here the boundaries from 0 to 5. and also this one. So you will notice here, we have the variable, we have the boundary of your time, which is from greater than 0, but it is less than the value of your period. No, so we have here the boundary from 0 to 1 period. So looking here, we have here the boundary from 0. Okay, so let's go back to 1. Substitute natin here, so 0. Now the function, so again, so yung function natin, so balikan natin yun, no? So for the function here, so ito yung function natin yan. So that is defines yung functions natin. So let's try to substitute that one sa equation. So that will be a, no? So we have your time. So this is all over yung value natin ng period, okay? And this is multiplied by your cosine, okay? And close parenthesis. So yung n, so n pa rin yan. Then we have here your phi, and this is all over. Now, for the value of your x, no, since the variable natin, so x defined as yung variable doon sa equation. So ang variable natin dito, we have your t, no? And for the value of L, okay, so again, remembering that define, no, so going back here, the period is equal to 2L, no? So we're looking for the value of L, so eventually, substitute natin yung period, then divided by 2. So let's try to do that one. So we have, for the P, so my P is, again, that is 2L, no? So, ang kailangan ko is P, so that will be my period, no? And this is all over divided by 2. Yeah. Okay, so that defines sorry. Oh, okay, so the value of P. Divided by 2. So this defines, or let's say this, we can express this one, yung value ng period natin, that will be 2 pi times your angular velocity over 2. Or let's say it can be rewritten as my, so usually cancel naman yan. So ang may iwan na lang, that will be pi, no? All over my angular velocity. So yun na maiiwan. Then we can substitute here sa equation. So that will be ano lang, pi all over my angular velocity, close parenthesis, and again, that will be dt na siya. Okay? And so let's try to rewrite this one again. So this is, express na natin ito in terms ng value ng period. So this will be 2 pi divided by angular velocity. So integrate natin to. Again, yung boundary natin, that will be 2 pi, no? 2 pi angular velocity, then you have your 0. And also here, yung function natin to, take out na natin yung constant dito. Eventually kasi ang constant is a, at saka yung period. So ilalabas ko na yan siya dyan. So we can again rewrite yung equation later on. So that is already on the ilalim niya, which is period na. And this will become my t, and this is for my multiplied by cosine. And dito naman, so we can eventually cancel yung pi since they are common. So cancel na natin yan. So what is left is this one. So I can define na lang ito. We can rewrite this one as your n, no? Times the angular velocity times time. So yan. Then again, we have your dt dyan, no? And okay, so I can rewrite this one. So pwede ko siyang ilabas doon. So we have your a sub n. And this one, pala, pwede na rin natin ito i-cancel out. So this one will be cancelled out, and this one. Okay? So pwede ko na yan ilabas dito. And I can rewrite here. So this will become my angular velocity. That will be all over, no? Pi. Then, ito, yung a over my period. So ilabas ko na rin yan. So that will be my a. Okay? So that will be all over, and this is my period, no? Then integrating this one with the boundary of your 2 phi angular velocity and 0, and maiwan na lang dito sa loob, which is yung t cosine, no? We have here t, this is, so let me rewrite this one again. So cosine, so that will be n angular velocity times time, and we have your dt, yeah? So yeah. And I can further express this one. So let's try to break this one. Break natin to. I can express or break this one into component pa ng period. So that will be angular velocity. So this will be my phi, no? And my amplitude. And express this one, yung value niyan, that will be 2 pi angular velocity. Yeah? And this one, we have 2 pi angular velocity. So boundary 0. So we have t cosine. You have your n, no? Angular velocity, time, and you have your dt. Okay? So that define that one. Let me close this one. So again, I'm rewriting this one step by step, no? So ito, okay, akit ko na itong W. So I can rewrite here my constant dito sa harap na integration ko. So that will be angular velocity squared, and sa ilalim that will be 2 pi squared, no? So this one, integrate boundary 2 pi angular 0. We have your t, no? Cosine. We have your n, angular velocity times time, and we have your dt dito, no? So yeah. So from here we can concentrate purely dito sa loob. Now eventually what we're going to do here, we will be using integration by parts, no? So let me write here the equation of my integration of parts. Since we cannot uh, solve this one individually, we're going to have to do an integration of parts, no? Okay, so integration of parts by parts. So we have the equation integration by parts. So we have your u, right? So we have the derivative, no, of your b. Okay, so that is equal to u times the v minus the integral of your b and your du. Okay. Now for the first part, for my first part here, so I'm going to define the value of my u, no. So the value of my u is t. So from here, so first part that will be u, that will be t, no. Um, then next we have so let's try to make a derivative of this one. So I will try to make derivatives. So I'm gonna write here to for you to follow this one. So let's have make a derivative, no? Derivative of both sides. So eventually we have that will be du and dt. Yeah. So derivative of both sides. So I'm gonna write here both sides. Okay. So then for the second part, uh, we have no. So for the second part, so that will be dv, no? So for my dv, so this will be equal, no? So again, we have this one for the second part. So this is equal to cosine n angular times time, and we have your dt, no? So let's integrate this one. So integrating both sides. So I'm gonna write here para you can follow along. Integrating both sides yan. So I'm going to integrate my dv here, which is integrating doon sa kabila. So that will be cosine yung n, angular velocity times time, and we have your dt. Yeah. So eventually, if you integrate the dv, so this will be resulting as a v. And ito, okay, so we need to do a variable substitution here, no? So I'm going to let, no? So let me substitute apply a substitution of variable here. Substitution of variable natin dito. So I'm gonna let, no? So let me assign, no? So here, so let for example, so I'm going to use uh, x, no? So let x, so to define yon substitution, and angular velocity times time, then I can, ano ito, rewrite, no? My equation here, x, so all over, n, angular velocity, and we have your time, no? Then, I can derive this one. So, I'm going to do is differentiate, no? So, differentiate both sides ng equation natin dyan. So, I'm gonna write here so that you can, para hindi kayo malito. So, differentiate both sides, which is yung variable natin dyan, which is yung x tsaka yung t. So, I can rewrite this one as a dx, di ba? And this is where your n, which is yung constant, tsaka yung angular velocity, which is constant. Then, this one, differentiate natin, so that will be dt, okay? Then, I can substitute dito sa equation natin yan, yung values na yan, no? So, I can rewrite here. So, substituting. So, I'm gonna write here. So, dito na lang. Equal natin yan. So, that will be f. Integrate. So, cosine. Now, this one, anong value natin to? So, that will be n angular velocity times, and naglet na tayo. So, substitution by variable. So, that will be cosine of x. No? Then, the value of my dt. So, ang value ng dt natin dito. So, kanina, nag-differentiate na tayo since we need to differentiate that one, para equal. So, that will be dx, no? Dx all over your n, tapos yung angular velocity. So, we can rewrite this one. So, pwede natin i-take out na yung constant dito, which is eventually ito yon. So, I can write here 1, no? Over your n, angular velocity, tapos integration, which is cosine of x, yeah. Then maiwan, which is your dx. So again, going back from your integral, so this is can be integrate already, no? Since it is satisfying the relay to the integral niyan. So satisfy na yan. So I can rewrite here that will be 1 angular velocity. Usually, if you're going to integrate the cosine of x, so eventually, the answer is yung sine, di ba? So, if you're going to integrate that one. So, this is multiplied by your sine. So, I'm gonna replace this one bracket. So, let me bracket here. So, that will be sine. That will be close parenthesis, x. Okay. So, that is define yung values na ito, no? Now, looking at the overview, okay? So, meron na tayo ng value ng u, which is yung t, and yung v. Meron na tayo yung, which is yung value ng v natin. Ito yon. Okay? And meron na tayong du, where your du is your dt. So, we can substitute na dito sa equation na ito, no? So, we can further rewrite yung equations natin satisfying yung integration by parts. So, I forgot, kailangan pala natin muna i-express ito. So, rewriting this one. So, I can rewrite yung ito, no, in terms, no? So, let me try to do that. So, that will be 1, no? So, ibalik natin yung values ng x. So, that will be n, angular velocity. So, this is close parenthesis. We have your sine. And the value of x, so ito yon. So that will be n angular velocity times time. So again, close natin yan. So that will be the value ng v natin. No? So looking out to the overview ng solutions natin, so pwede na natin i-substitute yung mga values na ito doon. Okay? So let me try to do that. So again to, yan, balik natin dito. Okay? or let's say we can rewrite mu dito. So just here, no? So that will be the integrand of u dt. Okay. So again, i-express natin yan. So the value of my u, yan, ito, yan. So that will be, okay, so tingnan natin doon. So the value of my u dito, going back, sana yan? Okay, yun. Okay, so that's it. So the value of u, express natin yan, that will be t. Okay, so I'm gonna write here t. Okay, so t, no? Then, again, we have your b. So, balikan natin doon. B natin, this one. Okay? So, from here, going here. So, yan. So, para hindi kayo ma-confuse. So, we have this one. So, I'm gonna write here. So, that will be multiply yung 1 all over your n angular velocity. Then, this is sine. No? Close parenthesis, my n angular velocity times time. Okay? So, that defines yung ano na ito, first term, no? Then, minus, no? So, we're going to do is a minus on this one. Since yung nakalagay doon is minus, no? The value of v, so yun, integrand nito. Okay? Integrate natin nito, minus the value of v, which is, ito pa rin yun. So, that will be 1 over your n angular velocity. Okay? Then, times my that will be sine, no? Value angular velocity times time, no? Okay, so dito we have here karunong that will be 1 over u and du pa, no? So go back, balikan natin. So yung du natin, that is dt, di ba? So I'm going to substitute that one here. So I'm gonna write here as my dt, no? So let me concentrate now on this part. So from here, so I can say my derivative of this one, u db. Okay, so I can rewrite my equation here, t, no? So this is all over, that will be n, angular velocity, and we have here multiplied by sine, and angular velocity times time. And this one, so from here, so pwede natin ilabas yung 1 over nw. So since this is a constant one, so that will be 1, no? So that, sorry, let me, all over. So that will be n angular velocity. So yeah. Then we have here the sine times n angular velocity times time, and this will be is dt, no? And again, this is all in a boundary pa rin, no? In a boundary of your 2 pi 2 pi w and yung 0. So later on, i-express natin yan. So let me try to focus on this one now. So we can apply, no? So let me try to focus on this one so we can apply a change in variable on this one. So we have here substitution by variables at this one, no? So again, what I'm going to do here, so I'm gonna let, no? So I'm gonna let z is equal to yung value na yan. So that will be n angular velocity times time. And I can rewrite this one as n angular velocity, and this is my t, no? Okay, and again, so I can differentiate this both sides here, no? So that we can substitute natin yan doon sa equation later on. So this will be differentiating. So to differentiate this one, we have that btz, no? Angular velocity, and the other side we have your dt, no? So differentiating on both sides. Then I can substitute doon sa equation, so I can rewrite my we call this sine, no? That will be n angular velocity times time, that will be your dt. So by means of substitution na yon, so pwede kong i-write na yan as my sine, no? Di ba? Times yung n times the angular velocity times time. So again, this is the value of z. So I can write that z, and the value of my dt, so this one will be dz, no, all over n times the angular velocity. So from here, mapapansin nyo, we have the constant that is nw. So again, so pwede ko ilabas yan, all over n angular velocity. So that will be sine, no? That will be z and dz. Yeah. So this one can be, pwede natin i-integrate, no? So we can integrate this one. So that will be 1 over your angular velocity. So integrating the sign, so that is equal to negative cosine. So I'm gonna write here negative. So this is will be negative cosine of z, no? Then I can write here 1 over my n angular velocity. So that is negative already, no? Cosine. Now for the value of z, so going back, value of z, that will be n angular velocity times time. So yun, substitute natin doon, n angular velocity times time. Okay? So that is now equal doon sa value no. So let's have a quick overview on this one. So pwede na nating ibalik ulit doon sa equation na yon. So from here, we can integrating this one. So substitute natin doon. Okay, so let's try to do that one. Okay, so dito, no? Yan, we can substitute here doon. So again, so from dito, from here yung solution natin. So I can rewrite here. So again, dito balikan natin to, no? We can rewrite natin yung values na yun. So I can say here, no? So rewriting the equation here. So we have your uh, wait, so let me try to paste. Okay, so I'm gonna draw a close bracket dito to para pasok natin yon. So that will be negative, no? All over. So that will be your n, no? Angular velocity. So this is cosine, that will be n angular velocity times time. So again, close bracket ko ito, no? So we can multiply, pasok natin doon, distribute natin yan. So I can rewrite here equation. Okay. So pasok natin doon, that will be so yun, negative, negative, it will become now positive, diba? So this is 1 all over, no? So this will be n squared, and we have your angular velocity squared, no? So this is cosine n angular velocity times time. Okay, so that defines yung values natin doon. So let's try to look the overview, no? Integration by parts natin dito. Okay, so we can substitute yung values na ito, no? From there, no? And also take note of pala, no? So we have the boundary, no? That will be 2 pi angular velocity, no? And that will be 0. Okay, so let's have a close bracket on this one to represent one, no? So this will become as my close bracket dito, no? Since this is still in the boundary of your 2 pi angular velocity times and also 0. So upper boundary and lower boundary, which is 0. So let's go back, substitute natin yan doon. This one will be continue natin dito sa solution na yan. So let me try to arrange muna. Now, I will be drawing a line here, top path, no, para masundan niyo. So you can follow along. So yung solution natin dito. So from here, okay. So we'll draw a straight line to show you kung saan na tayo. Okay, so this will be yung part na yan. Okay, so we have this one. So substitute natin, since na integrate na yan, we can substitute here to the equations, no? So I can rewrite my equations here as yung constant na ito, then multiply in this one. We have this one, no? Now I can factor, no, so that we can achieve yung uh, solutions from the book. So para we can say that we are on the also in the right path, no. So usually if you're going to refer to the book, so solutions is gonna flash here yung book. Okay, so para we are on the same page. So usually the solutions from the book, okay, I'm gonna flash dito. Okay, so we have here solutions of the book. So is in this type of form of my equation, no? So I'm going to factor something there sa equation ko so that we can satisfy also this one, proving also the solution from the book, and my solutions are the same, no? So let me try to do that one. Okay. So what I'm going to do is to factor yung values ng angular square dito. So eventually kasi ilalabas ko lang siya. So I'm gonna rewrite this one. So that will be no all over, no. So this is my 2 pi. Okay. 2 pi squared. So eventually ilalabas ko lang din yung w squared niya dito, angular squared niya dito. Okay. So I'm gonna close parenthesis this one. And in order to satisfy ito, so I'm gonna multiply here t, so angular velocity. So eventually pag pinasok mo doon sa loob, it will be cancelled out. So eventually lalabas yun siyang ganyan, di ba? So I can write here that will be my n, no? And this is sine n angular velocity times time, then plus na dito, then we have your 1. That will be all over. So that will be n squared na. So since wala na tayong pinactor natin, so we can multiply this one, cosine n angular velocity times time. So again, close parenthesis natin ito. We have 2 pi angular velocity and we have a value of 0. So we can substitute now yung values nito. First things muna, we have to cancel this one. So this one will be cancelled out. So let me try to change the color here. It's red. Sorry. Let me go back here. So nawala. Okay. So this one is red. Cancel out. Cancel out. So we can write here that my A. No? So let me change the color here. So my A. No? So that is all over. So that will be 2 pi squared. So this is close parenthesis. So yan, yung buong equation yan, we have t angular, no, time times your angular velocity. We have your n. Okay, so this is will be my n times your sine n angular velocity times time. Then we have your 1. Okay, so this is all over yung n squared natin. Then this is cosine, and this is n angular velocity times time. Okay, and we have the boundary which is 2 pi angular, and this is 0. Okay, so that this one satisfy yung from the book. Okay, now we need to prove that this will be also equal to 0, no? So again, we're going to substitute the values here. So we have your a. Okay, so this will be 2 pi, no? 2 pi squared. So close parenthesis. So variable natin dito, that will be t. So I'm going to substitute this one, no? Sa loob. So that will be 2 pi times your angular. That will be times your angular also here. And all over. That will be your n. That will be my n times my sine. So this is sine, my n. And this is my angular. And the value of t. So this is 2 pi divided by my angular, close parenthesis on this one. And also, siyempre, we have yung minus here, which is 0, no? So, just to show you, so to properly demonstrate this one, so I'm gonna minus this one. So, we have here yung value ng t, which is your 0 naman siya. So, 0 yan siya doon. So, that will be 0. Okay, times your angular all over. Divided by your n. Then, this is multiplied by sine. Yung n, angular. Then, this is will be 0. So, eventually, yung value part na ito, it will be 0 out. No? Then, next, we have your plus. So, this is 1. No? All over. That will be n squared. And ito naman, we have your cosine. So cosine, then we have your n, angular, and also the value of t, that will be 2 pi, no? So let me, 2 pi angular, okay? So that will be t, that will be 2 pi angular, and minus nito. So that will be 1 minus your n squared, then we have here cosine, okay? So this will be n angular and multiply by 0. Okay. Yan. Then going to close parenthesis ito lahat. Okay. So that is one whole equation. No? So let's try to sum out. Okay. To see, to have a overview ng solutions natin dito. Okay. So magka-cancel out, what we have here, magka-cancel out. This one will be cancelled out and this one. And eventually this one will be 0 na rin. So let me, so this is will be 0. And cosine n25, so this one will be cancelled out, and this one. Okay, so this is cosine of 1 na lang, and we can further rewrite here. So this is a, that will be mm, all over now. So this is 2 pi squared. Yeah. And this will be close parenthesis. So eventually dito naman magka-cancel out din nito. So I can cancel this one and this one. So my E1, which is 2 pi, okay, and this will be all over your n, and this is sine 2 n pi, right? Okay, and this will be, ito ay 0 na, so we have your plus dito. This will be 1 over your n squared. So, and this one is cosine, will be 2 n pi, okay, and this one will be minus, that will be 1 over your n2. So we have your cosine, and this one will be 0 out, no? Kasi every number that is multiplied by 0, so eventually will give you a 0 values. So that will be equation now. So I'm gonna write here where, no? So where, no? For the values, my sine 2 and 5, this is equal to 0, and my cosine, so my cosine 2 and pi is equal to 1. Okay, so eventually this one will be cancelled out and this one will be equal to 1, so I can write here, so this is a all over, so this will become 2 pi squared. So close parenthesis, no? So this is will be 0 out. So 0 na yan. 2 and 5 is 0. And ito ay maiwan as 1 over your n squared. Since your cosine 2n phi, that will be 1, okay, and minus 1n squared. And cosine, no, cosine of 0 is equal to 1. Okay, so this is multiplied by 1. Okay, close parenthesis natin yan. And what is left here is, so this will be 0 out. So, eventually, ang a sub n mo is equal to 0. Okay, so let me try to highlight this one. Okay, so this will be cancelled out naman kasi it is 0. Okay, this one will be 0 out also. Okay, so substituting that one, so a sub n is equal to 0.